Right triangle trigonometry. Welcome to it, peeps. It's one of those skills that we need. Remembering back to the Karate Kid, wax on, wax off, and scrub the floor or paint the deck or hey, whatever the case may be. We need these skills to do some really cool things to describe motion and all sorts of other aspects in physics. So, without further ado, let's take a look at a right triangle. Here it is in its full splendor and glory. We have the hypotenuse, the opposite side, the adjacent side. What makes a right triangle, of course, is the fact that two of the sides are perpendicular to each other. The adjacent side is perpendicular to the opposite side. They make a 90-degree angle perpendicular. And the hypotenuse, as we'll see, is the longest side in the triangle. All right, let's look at basics in this lesson, and then we'll go through some case examples of how we can analyze the triangle, and it will benefit us later on when we study motion in full. Okay, so the basics. The hypotenuse is the longest side, and it's subtended, awesome word, by the largest angle, which is 90 degrees. Subtended is a fancy word for framed, or like yay, okay, so my arms are now subtending the ceiling fan that's above me. It just means to subtend. You open your arms and welcome something. Okay, you're subtending. That's what it means. And so over here we see that this is the right triangle with the 90-degree angle subtending the hypotenuse. There are certain relationships that we will study and make use of these relationships to do some analysis. For example, angles. All the angles in the right triangle. The sum of them, all three, is 180 degrees. Actually, that's with any triangle, but it's an important property to use in case we need to figure out what the angle might be, and we know two of them. So it's very easy to do in that case because their sum is 180 degrees. The sides. We'll use the Pythagorean theorem. You guys are probably quite familiar with it. I write it like this rather than the a squared equals b squared plus c squared format. I prefer hypotenuse because it's very descriptive as to which side we're talking about, and that's important when we physically look at what these sides will represent in the physical world. So, for example, here we have hypotenuse squared, that's the longest side, equals the sum of adjacent squared plus opposite squared, like so. Okay, so this is the format that we'll be using that is more descriptive than what most math courses will use. All right, and angles and sides will be studied using SOHCAHTOA. It's a relationship of trigonometric identities, ratios of the sides that produce angles. So it will give us a relationship between angles and sides. All right, now why is this important? It's important because right triangle trigonometry allows us to model and analyze motion in 2D and 3D. So far, all we've done is motion along a line, okay? Basically like a number line, positive side, negative side. We can go maybe north and south, but so far we haven't incorporated east and west. Can we go northeast now? Absolutely. We can do that because of right triangle trigonometry. So here we go. Once again, hypotenuse. Hypotenuse, we'll be using that far more than 10 times. Adjacent, we'll be using it even more than 100 times. And the opposite, self-explanatory. Okay, that's it. On to looking at the Pythagorean theorem and analyzing sides, a case where we'll be solving for sides later. Angles and sides, SOHCAHTOA. Morad, out.